Right, this first cubic, y equals x take 2 times x plus 5 times x take 1. I'm not going to expand the brackets because I don't need to, but I'm going to think, if I expanded the brackets, would the x cubed term be positive or negative? I hope you can see the x cubed term would be positive in this case, because it would come from positive x times another positive x times another positive x, so it will be positive. Before we have this general shape, and you need to be very familiar, comfortable with that shape. So that shape, and it goes through the x-axis at 2, minus 5, and 1. Goes to the x-axis at 2, minus 5, and 1. So we can search for that in the 6 graphs, x-axis at 2, minus 5, and 1. Well, you see the last 2 graphs here don't have numbers on the x-axis. So we know it's not the first one, not the second, not the third, not the fourth. X-axis at minus 5, 2, and 1. So it must be this one on the right. Minus 5, 2, and 1. It can't be the one on the left because it crosses the x-axis in negative places. So these numbers, they couldn't be minus 5, 2, and 1 because they're on the negative x-axis. Therefore, graph number 1 is this last diagram here. And it was x plus 5 in the brackets. That's what made it go through the x-axis at minus 5. X take 1 and x take 2. The x take 1 made it go through the x-axis at 1, and the x take 2 made it go at 2. We also need to put on, where does this go through the y-axis? So this point here, it's really easy. At this point, we know x is definitely 0 because it's on the y-axis. So when x is 0, y is. Now again, we don't need to expand the brackets. We do not need to expand the brackets. Just sub in x is 0. First bracket is 5. Second bracket is negative 1. Third bracket is negative 2. And then 5 times negative 1 times negative 2, which is 10. Graph number 2. We've got a quadratic times a linear factor. If we can factorize the quadratic, then that would be very useful. It doesn't always factorize. Yeah, you might be given a cubic like this where the quadratic cannot be factorized any further. That could happen. But in this case, it can be factorized. So now it's fully factorized. We can see we've got a repeated root. We've got the same bracket twice. And if we fully expanded the brackets, it would be a positive x cubed. So it's this general shape. A repeated root when x is negative 2. So when x is negative 2 and y is 0, we get either a maximum point or a minimum point. And it'll also go through the x-axis at negative 6 as well. So let's search for that. So the turning point when x is negative 2. Sorry, just remember this diagram here, the curve and the line have slightly gone out of position. This is supposed to be it bouncing off the x-axis here. Yeah, the horizontal line, the x-axis, is slightly too high. It looks like it's crossing the curve twice. It's not supposed to. It was meant to just touch the curve. So that is graph number 2. That was graph number 2. Find where it crosses the y-axis when x is 0. The first bracket is 12 and the second bracket is 2. 12 times 2 is 24. So apologies for the diagram being slightly wrong there. The third one, fully factorized already. It's number 3. If we expanded it, once again, it would be a positive x cubed graph. So that's the shape. This time going through the x-axis at -6, -2, and 3. And here it is. We need to find where does it cross the y-axis. As usual, very easy. Sub in x is 0. When x is 0, we've got 6 times 2 times -3, which I make -36. Now, so far I've done the first three graphs by looking at the equation and then working out where it goes through the x-axis and so on, and the shape. I can also work backwards. So let's take a look at this one here. Just by looking at the graph, it is possible to work backwards and figure out its equation from there. So here we have it crossing the x-axis at 1 and 3 and 5. I'm just going to leave a little space after the equal sign here before my brackets. So if I had x take 1, x take 3 times x take 5, then that would pass through the x-axis at 1 and 3 and 5. However, note the shape. This is the shape of a negative cubic. It goes up to positive infinity on the left, down to negative infinity on the right. So this is not a positive cubic graph, this is a negative cubic graph. So it needs a minus in front. Now there might also be another number in front here. This is one thing we can't tell unless we have the number on the y-axis, but at least we can now go back to the list and figure out which of those it is. Now before we look at the list, this minus at the front could go inside any of the 3 brackets. Not all 3 of them, just one of them. For example, this graph could be written as, if I absorb the -1 into the first brackets, x would become negative and the -1 would become positive. So I could write it as 1 take x. So I could write it like that. Or the minus could be absorbed into the middle bracket instead. Once again, it's not going to go in all 3 brackets. We don't have 3 minus signs. We've only got 1. So it could go in any of the 3 brackets. We go back to the list of equations. If we look at number 5, that is the one that looks like our equation, but we can see the minus has been absorbed into the middle bracket. Like I said a moment ago, the minus could go in any of the 3 brackets, not all 3, but only one of them, and it turns out it's gone in the middle bracket. So if we absorb the -1 into the middle bracket, that x becomes negative and the -3 becomes positive. We could write -x add 3, but it's neater to write 3 take away x. It's the same thing, of course. And there we have it. So now we have the equation of the curve. We need to see where does it cross the y-axis. When x is 0, we get -1 times 3 times -5, which is positive 15. I'm going to do a similar thing working backwards for these two as well. I'll do the one on the right first. So it's a positive cubic. And it goes to the x-axis at -3. So that'll give me a bracket of x plus 3. And then a bracket of x plus 2, because it goes to the x-axis at -2. And then x take 4. Now it is possible that there's a number in front of these brackets. But since we're now looking at a list of possibilities, we can figure out which of the possibilities it is. Let me just emphasize that there could be any number in front of these brackets here, like a 7 or 9 or 22. There could be. We've got the advantage here of being able to look at the list and see whether there is a number in front. And we don't see it straight away, but if you notice, the sixth equation here has a quadratic, which in this case can be factorized, and we get our 3 brackets. Where does it go through the y-axis? An x is 0, the first bracket is 3, the second bracket is 2, third bracket is -4, so I get -24. And the final one, although we could just write down this equation because it's the only one left, let's do the working backwards trick. Notice it has a turning point when x is 5. That means we're going to have repeated brackets, a repeated root, and it also goes through at -2. So it's going to be x minus 5x plus 2. It's a positive x cubed graph. So when I expand the brackets, I need to make sure the x cubed term would be positive. Finally, again, there could be a number in front here. Could be a 2, could be a 3, could be 50 million. There could be a number in front. If we go back to the list and if we look at number 4, this is the one we've just drawn. X take 5 times another x take 5 times x plus 2. There's no number in front of the brackets. So now we can figure out where it goes to the y-axis. That's going to be -5 times -5 times 2, which is 50.